Somewhere beneath the frozen ground of Siberia, a body has been waiting. Not a skeleton, not fragments, a body. With skin, with hair, with stomach contents still intact. It has been waiting for 4,000 years. This is a woolly mammoth, and the fact that we can look it in the face, the fact that its eyelashes are still there, tells us something extraordinary about the world it came from. This video is about an animal that walked the earth until yesterday, in geological terms. An animal our ancestors hunted, painted on cave walls, and feared. An animal that is now being brought back from extinction in a laboratory in Texas. This is the story of the woolly mammoth, and it is not over yet. When the first mammoth bones were found in Siberia centuries ago, nobody knew what they were. Local people called them Mammoth, a creature they believed lived underground and died when it surfaced into sunlight. That's how strange these bones seemed. That's how little context there was. Here's what makes mammoths unlike almost any other extinct animal. With dinosaurs, we work from stone, bone that has been replaced molecule by molecule with minerals over millions of years. With mammoths, we have the actual biological material: hair, skin, fat, muscle tissue, blood, DNA. The permafrost of Siberia is the largest natural freezer on Earth, and for 10,000 years, it has been preserving these animals almost perfectly. In 2007, a reindeer herder in northwestern Siberia stumbled across something in a riverbank. A 1-month-old baby mammoth, female, every organ intact, eyelashes still attached. They named her Lyuba. She died 42,000 years ago. She looks like she died last week. Lyuba is now considered the most complete mammoth specimen ever found, and she has told us more about mammoth biology than 100 skeletons combined. Let's look at the animal itself. The woolly mammoth was not dramatically larger than a modern African elephant. A big male stood about 3.4 meters at the shoulder and weighed around 6 tons. But everything about the design was different. Purpose-built for cold. Those tusks could reach 4 meters in length. They were not weapons primarily, they were tools. For scraping ice off vegetation, for digging through snow to find food, for pushing trees aside. The ears were tiny, 10 times smaller than an African elephant's, because large ears lose heat. In Siberia, you cannot afford to lose heat. Beneath that thick outer fur was a dense undercoat of fine wool. Beneath that, a layer of fat up to 10 centimeters thick. And the blood. Scientists have analyzed mammoth hemoglobin from preserved tissue and found it was chemically different. Modified to deliver oxygen efficiently in extreme cold, the way antifreeze stops a car engine from locking up. Mammoths were not solitary. They lived in herds, structured the same way modern elephant herds are today. Matriarchs leading. Young males eventually leaving, calves protected at the center. They communicated through low-frequency rumbles, sounds too deep for humans to fully hear, traveling through the ground for kilometers. They grieved their dead. Elephant behavior today gives us the best proxy we have, and elephants have been observed returning to the bones of dead family members, touching them, standing in silence. There is no reason to think mammoths were different. These were not monsters, they were families. We tend to imagine the world of the mammoth as empty, a barren, frozen wasteland. That is completely wrong. The landscape mammoths lived in was called the Mammoth Steppe, and it was one of the most productive ecosystems that has ever existed on this planet. It stretched from Western Europe all the way to Canada, across land that is now the bottom of the Bering Sea. It was a cold grassland, but not a dead one. Thick with grass, flowering plants, shrubs, and it was crowded with life. Alongside the mammoth lived the woolly rhinoceros, armored, short-tempered, equally enormous. Cave lions, twice the size of the lions alive today, hunting in coordinated groups. The Irish elk, an animal with antlers spanning 3.7 meters, wider than a small car. Giant short-faced bears, steppe bison, horses, reindeer in numbers that are difficult to imagine. And one more species, walking upright, carrying spears. Our ancestors and mammoths shared the same world for at least 30,000 years. They painted them on cave walls, in France, in Spain, in southern Russia. They built shelters from mammoth bones, entire huts constructed from tusks and femurs. We have found them in Ukraine, in the Czech Republic. They wore mammoth fur, they ate mammoth meat, and they watched the mammoth disappear. Around 10,000 years ago, the great megafauna of the Ice Age vanished, not just mammoths. In North America, the mastodons, the short-faced bear, the American horse, the giant ground sloth. In Europe, the woolly rhinoceros, the cave lion, the giant deer, gone within a few thousand years. That pattern demands an explanation. 2 suspects have been on trial for over a century, and the jury is still out. The first suspect, climate change. The ice age was ending, temperatures rose. The Mammoth steppe, that vast cold grassland, began to shrink, replaced by forests and boggy tundra that mammoths couldn't easily feed in. The second suspect, us. Humans had just arrived in the Americas, and everywhere Homo sapiens appeared, in Australia, in the Americas, in the Pacific Islands, a wave of extinctions followed. Here is the detail that changes everything. On Wrangel Island, a remote patch of land in the Arctic Ocean, a small population of mammoths survived. Not 10,000 years ago, not 8,000. The last woolly mammoths on Earth died around 1650 BCE. That is 4,000 years ago. The pyramids of Giza had already been standing for 1,000 years. When the pharaohs of Egypt were building their empire, mammoths were still alive on Wrangel Island. They were not prehistoric in the way we imagine. They were recent. They were almost us. Those final mammoths were not the giants of the steppe. Island conditions had changed them. Smaller food supply, smaller territory. Over thousands of years, they shrank. Wrangel Island mammoths stood about 1.8 meters tall, the size of a large horse. Island dwarfism, evolution compressing a species in response to resource limits. The same process that produced dwarf elephants in Sicily and dwarf hippos in Cyprus. They survived for so long because humans never reached the island in time. When they finally did, the mammoths were gone within centuries. Every year, the melting permafrost of Siberia surrenders more mammoth remains. Tusks, bones, occasionally entire bodies. And every year, a significant portion of that material enters the commercial market. Mammoth ivory is legal. It has become a substitute for elephant ivory, fueling a multi-million-dollar trade in carvings, jewelry, and luxury goods. The economics are straightforward. A complete mammoth tusk can sell for over $50,000. A full skeleton reaches the millions. The scientific cost is harder to measure. Every specimen that disappears into a private collection takes its chemistry, its isotopes, its DNA, and locks it away. There is something deeply strange about this moment in history. The permafrost is thawing because of climate change, and as it thaws, it gives up the mammoths. The same warming that is destroying the Arctic is defrosting an archive of Ice Age life that has been sealed for 10,000 years. New specimens are emerging faster than science can study them. We are racing to understand these animals before the conditions that preserve them, and the planet they help us understand, are gone. In 2021, a company called Colossal Biosciences was founded with one stated goal: bring back the woolly mammoth. Not as a theme park attraction, not as a stunt, as a genuine act of ecological restoration. The science behind it is called de-extinction, and it rests on a tool called CRISPR, a molecular editing system that allows scientists to make precise changes to DNA. The plan is not to clone a mammoth from scratch. It is to take the DNA of an Asian elephant, the mammoth's closest living relative, sharing 99.6% of its genome, and edit in the key mammoth traits: cold-adapted hemoglobin, fat metabolism, thick hair, small ears, and dozens of other changes. As of 2024, Colossal has made genuine progress. They have successfully edited multiple mammoth genes into elephant stem cells. They have created cell lines with mammoth cold resistance traits. They have announced plans to have a living, cold-adapted elephant calf within the next several years. But let's be precise about what that means. NS. The first result will not be a mammoth. It will be an elephant, with some mammoth characteristics. A fully mammoth-like animal, if it ever exists, is decades away, possibly longer. And even if it is born, where does it go? The mammoth steppe no longer exists. The ecosystem it evolved to inhabit is gone. There is a deeper question underneath all of this. Do we have a responsibility to bring back what we destroyed? The evidence increasingly suggests that humans, our ancestors, played a significant role in pushing the mammoth to extinction. If that is true, does that create an obligation? Or does de-extinction distract us from protecting the species that are disappearing right now, today, while we watch? There is no clean answer, but the question matters, because the mammoth is not just a scientific puzzle, it is a mirror. It shows us what happens when a world is remade too fast for its inhabitants to adapt, and it asks us, directly, whether we are paying attention this time. Somewhere in Siberia, the ground is still giving up its secrets. Bodies that have been waiting 10,000 years are surfacing, slowly, reluctantly, layer by layer, and in a laboratory, cells are being rewritten. Old code, read again for the first time. The mammoth did not leave quietly. It left us its DNA, its bones, its painted image on the walls of caves. It left us everything we needed. The question is, what we choose to do with it.